Okay, let's do an example. Here we are. Pause and copy. So here's a funny looking function, and we're going to choose a to be 1 and b to be 3. A to be 1, b to be 3. So what do? We want to build this integral over here. So I'm going to do it step by step. I'm going to start by finding the derivative. That's fairly straightforward. Y prime. Okay, of course, this is also known as y prime. And then I want to square it. Okay, so I'm going to square that. Okay, work out the expansion here. Now what's the next step? Well, the next step is to add 1, right? You want to have derivative squared and then plus 1. So I do that in my next step. And what happens? Well, I had minus a half, right? This is minus a half. It becomes plus a half. And now we still have this square root to deal with, because you'll remember that in the integral, this expression here is appearing beneath the square root. So that's a problem. Okay, that is a big problem. You'll remember from integration techniques that integrals involving square roots can be a lot of trouble. Okay, we may have to resort to trig sub or even worse. Okay, there's, in general, difficulty with square roots in integrals. But thankfully, we've cooked up this example in a very nice way so that we actually have a factorization of this expression. Now I'm saying here I factorized by guess and check. Well, what did I do? I said to myself, well, above I had x squared over 4 minus 1 over x squared. Okay, that's, when I squared that, you'll remember I did that up here. When I squared this, I got this. So, as part of my guess, I'm going to make an educated guess. I'm going to say, well, when I squared this, I had this expression with minus a half in the middle. So now, when I'm trying to factor this guy, I notice that I have a plus half. So what's the difference? I had a minus half here. Now I have a plus half. Why don't I try, instead of this factorization, why don't I try this one? And thankfully it works out perfectly. Okay, this is a bit artificial. We've cooked up these examples so that they factor this way, or sometimes we cook up the examples so that they factor nicely. And again, we are doing a guess and check, but if we look at what happened above, we're able to make an educated guess. Okay, so the minus just becomes a plus. And I'm motivated to do that because this minus a half, which gave this factorization, suggests that this plus a half is going to give this factorization. Okay, enough. Too much talking. Okay, now I can form my integral. So arc length is, well, here's my definition, or my formula rather. Okay, I already worked out 1 plus y prime squared, so I just plug it in there. And then this square root here cancels this power of 2 here. All right, so again, we've cooked up a nice example that comes out nicely. And there's nothing left to do except grind out the details, which I do right here.